Greetings, dear friends, fellow programmers, and those aspiring to be. In this video, we are officially getting started with a new series. So, I would like to get started on the topic of data management and how to work with your data properly. So, in this series, we will be covering a whole bunch of different approaches and tips and tricks you can use in your day-to-day life to improve your data management very easily and successfully, of course. All the tips and tricks I will be discussing in this series are real-world examples and stuff collected from my previous experiences and things that I stumbled upon over my years of experience in working in the trenches, so you do not have to suffer through the pains of figuring them all out on your own. I mean, what else the friends are for, right? The first topic we have today is going to be dedicated to pagination. So, this might be a no-brainer for quite a few people who have some real-life experiences and are familiar with the concept of pagination, but we have to start off from somewhere. And what would be the better place than to do it from a very simple concept that is going to be fairly straightforward for everybody to understand. What is pagination? Basically, while working with larger sets of data, when you expect to have multiple rows in the database table, and you want to fetch a bunch of them, but not all of them at the same time, you can introduce pagination to ensure that your application is going to have better performance, better memory management, and better user experience, as well as scalability. So, these four pillars are the reason why you should consider introducing pagination whenever you can. So, let us discuss each of these points and make sure that we are all familiar with the reasoning why you should introduce pagination in your applications. The first point was performance. So, while we're talking about performance, just imagine your application needing to fetch hundreds of thousands or millions of rows from the database. This process would definitely take forever to execute. And basically in this period, your server is going to have a very difficult time handling multiple users at the same time, as well as the process of fetching and preparing that data is going to be very long-lasting and excruciatingly unpleasant for the user who is waiting for the data to get ready. And basically, that's when pagination comes to the rescue. By utilizing it, you will limit the number of results you want to send back to user and prevent all the data from the database from being fetched at the same time. This way, you will have a firm grasp on control over the data that is going to be fetched and returned to the user, and make sure that your servers are not going to die in excruciating pain. Now, the second point is going to be memory usage. And when we discuss it, it's fairly straightforward. When we fetch those hundreds of thousands or millions of rows of data from the database, we need to store them somewhere, right? We've got them from the database, but now we need to host them somewhere on our server and manipulate them, calculate something based on them, and prepare them for the user and send them to user. So, in this case, we need to save all of those records in memory, and when you have a lot of data, there is going to be a desperate need for a lot of memory, of course. And your server will not like this. So basically, again, pagination comes to the rescue, limiting the number of records we want to return at a single call. By that, we will not use too much memory at the same time. While we're on the subject of users having poor experiences, user experience is the third point we need to cover. So, when we fetch those thousands of rows of data, user needs to sit back and enjoy watching at the loader screen because it's going to take a while. For example, to fetch about 10,000 rows from the database, I'm talking about simple type of rows from the database, it will take seconds when you have very good servers to fetch those pieces of data and send them to the user. Now, just imagine how long it would take when you're fetching hundreds of thousands or millions of pieces of data. Now, that is going to be one hell of a poor user experience. And finally, we have scalability. So when you have multiple users trying to access your user application or whatever the UI is, whether it's API or whatever, and multiple people try to access some endpoint that requires a lot of data being fetched from the database and takes ages to execute, you will be very limited. You will not be able to serve too many users at the same time because your server is going to get overloaded by just one or two, maybe three customers at the same time. So you will definitely struggle to serve more people than that. Now I would like to show you two different methods that do exactly the same thing, but one of them has pagination and the other one does not. Behind the curtains, I created a small console app that will stopwatch our time needed to execute all the methods that we are going to test here, and I will be sharing the data we receive and in what time we receive that data. So the first methods we are going to check are going to be fetching customers, where we have 15 entries in the database, so it's a fairly small set of data, and we will be fetching them without and then with pagination, and then compare results. Our results make perfect sense because it took about double the time to fetch all the 15 rows we have in the database when compared to half the time that took to fetch 5 entries from the database, because the first method did not have any pagination and the second one did, and it limited the number of results we want to return to 5. And the second tip we have for the day are going to be compiled queries. So why do I want to cover this advanced topic right now, in the beginning of our journey for performance enhancement? So the reason is because I really like this one, and I do not think it's covered enough out there. So when you have a situation where you're constantly running the same query over and over again, but with different parameters, you can basically create compiled queries and substantially reduce the amount of time that it's going to take to execute those queries. And the reason why that is happening in the case with compiled queries is because they get compiled only once. This means that we have some ORM, in our case it's going to be Entity Framework Core, but it can be Dapper or NHibernate or whatever else you like to work with, and you are going to be writing in any of those ORMs in a language that is not direct SQL. And you need to convert the code you've written in those languages into vanilla SQL, which is going to be executed against the database. So in order to convert this process or compile it, your compiler needs to invest resources which are going to calculate what is going to be the final script to execute. And when you are working with compiled scripts, that is not going to be the case. They are going to be compiled only once and then reused every single time you reuse them. Of course, this comes at a cost that the first time when you execute your script, it's going to take a bit longer for it to be compiled when compared to regular uncompiled scripts, but when they do and you reuse them a lot, you will have a lot of benefits when it comes to performance because they will never again be compiled. So let's get stuck in the code and not spend any more time talking about it in theory. As you can see, in the first method, we are using a regular way using TP context and data sets to access the data and fetch the first user that has the ID that we provided. But in the second approach, we have a bit different situation. We have a simple helper method that is going to contain the actual compiled query. So as you can see, we have a part where we are execute ef.compileAsync query. This method that we just named is going to be the one responsible for creating a compiled query, where we will just switch the user ID and the query itself is going to be only compiled once and then reused over and over again. And to prove it, I will share 4 different types of data results and different timings, because as you can see, we have 2 scenarios where the first one is going to be fetching 5 users and the second one is going to be fetching 10 users from the database, where the first 2 executions are going to be performed using the regular approach and the other 2 executions are going to be utilizing the advanced compiled query approach. So let's compare the results. As you can see, our compiled query gave us a substantially less different times when executing it for 10 users when compared to 5. It's only 4 milliseconds a difference, while in the case of regular queries, it's 23 milliseconds, so it's basically almost 6 times more of a difference. So I highly recommend, whenever you are reusing certain scripts or certain actions or repository methods in your EF core, I highly recommend you to use compile scripts. But also be aware of the fact that when you are not using them many times, you will probably have more disadvantages and worse performance than you would benefit from it. But in those cases, when they do work, they are perfect. So, I think that was it for this video. We have to stop it somewhere, right? And I hope you enjoyed it. And if you did, please consider leaving a comment down there where you would like to specify some future data management skills you would like to acquire. So I would have stuff to cover, because I would like to do what you like and teach you what you would like to learn. Until the next time, thank you for watching and have an amazing day. Happy coding!